Okay, suppose that the goal here is to write the exact equation of this square root function. Now recall that there are two options. We can either play with this formula here, or we can play with a similar looking formula, which looks like this. How do I know which one to use? Well, the one that goes x minus h, that is reserved for the square roots that point to the right. Whereas this one here, it is reserved for the square root functions that end up pointing to the left. So let us play with, of course, this model here. So let's write this anew. So we're looking at y equals a square root h minus x plus k, where we look here, where this is called your start point, okay? Or your initial point. And its coordinates go in for h and k, respectively. So let's make those substitutions here. So we're looking at y equals. Now notice that h gets replaced by 3. There's no double negative or anything like that. It is a direct substitution. So we have 3 replacing h there, and then k gets replaced by 4. Now the only thing left to do is to discover this very specific value of a. And in order to find that value of a, you take this random point and its coordinates get replaced in for x and y. Okay? So let's take these values and deposit them here and here. So y gets replaced by -1. So we're looking at -1 equals a square root 3 takeaway. So I've carried the subtraction. Now deposit the value of x, which is a -46. And we know what happens with this here interaction. So we have -1, and this becomes 3. This essentially becomes 3 plus 46. Okay. Now, I would probably take this constant and move it over to this side. Let's just get it out of the way now before it causes any trouble. A goes here, little dot for multiplication. Give me the square root of 49. Okay, so something like that. And then we can divide both sides of this equation by 7. So that a equals -5/7. Now a quick FYI, you don't want to turn this into a decimal because it would probably not be exact because you would probably round it and whatnot. So leave it like this and take this a value and bring it back in right there. And that will constitute your final result. So we are looking at something that looks like this. And just a quick FYI, I have confidence in this answer, primarily because I know that it's correct, but also because notice that the curve opens down, which is consistent with the fact that a was a negative value.